Before you start this lesson, please make sure you've got a sheet of paper and a pen, as you will need to make notes and complete tasks. In today's lesson, we're going to be looking at the combustion of hydrocarbons, and by the end of the lesson, you should be able to write balanced equations for the complete and incomplete combustion of alkanes. So first thing to think about is what is needed for combustion to take place. So combustion is burning. And you're all, I'm sure, aware of the fire triangle. For things to burn or combust, you need a fuel, a heat source or an ignition source, and oxygen. You see combustion in the lab, especially when we use Bunsen burners. Now, methane burns in a Bunsen burner. Why does the colour of the flame change as you open or close the hole at the bottom? Well, I'm sure you know it's to do with oxygen. When you open the hole at the bottom of your Bunsen burner, you allow a lot of oxygen to flow into the Bunsen burner, and your flame is blue. When you close the hole, you limit the amount of oxygen available for the combustion process, and so your flame appears orange. And you're going to learn in this lesson why that colour change happens. So the hole open, the reaction taking place is complete combustion, because there is ample supply of oxygen for the reaction to take place completely. When the hole is closed, you have incomplete combustion, and this means that there is not enough oxygen for combustion to happen completely, and you get another product, which is called carbon monoxide. So let's look at complete combustion. So when alkanes burn, they react with oxygen, and complete combustion takes place if there is a good supply of oxygen in the air. The carbon atoms in the alkane are oxidised by combining with oxygen to form carbon dioxide. The hydrogen atoms in the alkane are also oxidised. They combine with oxygen to form water. I've written the equation for this reaction on the slide. Here is the symbol equation if you burn methane in oxygen to produce carbon dioxide and water. Now the fuel may change, but the reaction with oxygen and the products carbon dioxide and water remain the same. This equation isn't balanced yet, but we will have a look at balancing later. Incomplete combustion. This is when there is a poor supply of oxygens when alkanes are burning. And this can happen for a number of different reasons. The products are water along with carbon monoxide or carbon in the form of soot. The carbon monoxide formed is toxic and the soot causes a smoky flame, which is why the flame is orange. The two equations you need to know for incomplete combustion are that when a fuel, for example methane, reacts with oxygen, carbon monoxide and water is produced. And when methane and oxygen react, carbon in the form of soot and water could be produced. Now both of these reactions are happening at the same time during incomplete combustion. Now in an exam, you may be tasked with balancing combustion equations. So I wanted to give you some tips on how to approach the balancing of these equations. First thing you need to do is balance the carbon atoms. For each carbon in the alkane, there will be one CO2 molecule formed. So for methane, you only have one carbon, so only one molecule of CO2 is formed. But for ethane, where you've got two carbons, two carbon dioxide molecules will form. The next step is balancing the hydrogen atoms. For every two hydrogen atoms in the alkane, there will be one water molecule formed. The next thing is to count the number of oxygen atoms in all of the carbon dioxide and water molecules that will be formed in your reaction. Now the number of oxygen molecules that will be in the reagent is half this number. So for example, if you have one carbon dioxide molecule and two water molecules, That adds up to a total of 4 oxygen atoms. So the number of oxygens that are used in the reaction would be 2, half the number of oxygen atoms. Finally, if the number of oxygen molecules in the reagent side of your equation contains a half, you need to double all of the balancing numbers so that every number is a whole number. You might want to make a note of these steps in your notes. Let's have a go at applying the balancing. So copy and complete these equations in your notes. Pause the video while you do this. Great, here are the answers. So for complete combustion of methane, you're going to need 2 oxygen molecules to react with your methane, and this will produce 1 carbon dioxide and 2 water molecules. For the incomplete combustion of methane, the balancing gets a little bit more complicated. For the first equation, you have 2 methane molecules, 3 oxygen molecules reacting together, and they produce 2 carbon monoxide and 4 water molecules. You'll also have 1 methane and 1 oxygen molecule reacting together to form 1 carbon atom, which is soot, and 2 water molecules. Please make sure your equations are the same. Now, for a bit of extra practice, please pause the video and answer these questions in your notes, and then come back and we'll review the answers. Here are the answers to the questions you've just tried. Please make sure you mark and correct your answers. Right, let's have a go at a quiz. Question 1. What is the word equation for the complete combustion of a hydrocarbon? A. Nitrogen plus carbon dioxide, B. Carbon dioxide and water, or C. Nitrous oxide and water? Question 2. What is it called when a fuel does not have enough oxygen? Complete combustion, B. Incomplete combustion, or C. Combustion? Question 3. What poisonous gas is produced when a fuel doesn't have enough oxygen? A. Nitrous oxide, B. Carbon monoxide, or C. Carbon dioxide? Optional question 4. Give one symptom of poisoning from this gas. Answers. Question 1. The products of complete combustion are carbon dioxide and water. Question 2. When a fuel burns with not enough oxygen, it's incomplete combustion. Question 3. The poisonous gas produced during incomplete combustion is carbon monoxide. A symptom from poisoning of carbon monoxide are various. See below.